Special thanks to Skeptic7 for making me do this video, sort of. Could the law of identity be wrong? I'll have some links for law of identity in case any of you needed to brush up on what it was, but there's two different ways that we can address this and dismantle the law of identity. One is by focusing on the actual formula itself. A equals A. The first thing to note is that one of these A's is always going to be written or printed before the other A. So I wrote one of these A's at 1 o'clock, I wrote the next one at 2 o'clock, or maybe they were seconds apart or milliseconds apart, but nonetheless, they are not written at the same time. Now, of course, you could get clever and have a way to write them at the same time. Maybe you're ambidextrous, or you have a friend do it, or whatever, so you could maybe simultaneously write these two things, but even if you did that, there's a different problem. There's no way that you can have the A be in the same space at the same time as the other A. The space is different. So you have to give up one, either the time or the space. You can't have something be in the same space at the same time. So if we establish that each entity of A is in fact distinct from the other entity of A because they are not in the same space and or same time, then can we really say A equals A? After all, they're different in one sense. But somebody might object that A equals A isn't really talking about the A's at all. It's just referring to identity of a thing. A sheep is always a sheep, but that sheep is not the same as that sheep. And so what we've done is expose the problem of particular versus universal. A universal is a concept that we're conveying to each other. So if I asked you to picture in your mind or draw on a piece of paper an oval, you would produce a shape that matches that description. But the moment that you've done so, you've produced a particular oval, like this. If your oval is different than mine, well, it's no surprise because they're particular ovals. The oval, universal, is the concept of what an oval is. But you can't draw the concept. You just kind of know it. It's communicated to us via language and abstraction. But the moment that we try to put it into the real world, so to speak, it becomes a particular. So if A is referring to a universal concept, and the other A is referring to a universal concept, then all this is really saying is the universal concept is the universal concept. And it can't not be that because, well, that's what it is. And there you go. That's all there is to it. But that's not what the dang thing says. It says A equals A. It doesn't say universal concept versus universal concept. So therefore, we can still debate this. And so some logicians have. Now there is another way to address the law of identity, and it's quantum physics. Oh, good. I totally know how to cover that. Not at all. Alright, so in quantum physics, weird things happen, and I can't explain it properly, but I'll do my best. So you've got things like Schrodinger's cat, which is more like a thought experiment than anything else, but there's this thing called superposition where a thing is two different places at the same time. Well, what does that mean for the law of identity? Because, well, the thing is still the thing, but is it? You know, if a cat's alive, that's one sort of thing, and if it's dead, then that's a different sort of thing. But those, again, are particulars, and maybe we're addressing the universal. Okay, but then, of course, in quantum physics, you have particles popping in and out of existence, so could those possibly negate the law of identity? Since if it's not there, then it's not there, so if it's not there, it's not there. So the law of identity holds, but then it is there. So Now what? Well, if it's there, then it's there, so the law of identity holds. But if it's gone one moment and here the next, could it be that somehow that negates the law of identity? Some logicians have questioned this and said, we're not too sure because, again, we don't really understand quantum physics that well, and even if we do, we still don't understand it. I think it was Richard Freeman that said something to the effect of that if you think you understand quantum physics, you don't. And he, is a famous scientist that taught quantum physics. You can find some of his lectures on YouTube. I've watched some of them. No idea what he said. He said words. That's all I was like, okay, yeah, that's cool. Yeah. But it could be that as our understanding of quantum physics deepens, that logic might have to change to reflect reality. Right now, it doesn't seem that that's the case. It might very well be that A does equal A and the law of identity is fine as is, or it could be that this is an approximation, but it's never going to get us to what reality is really like, but it's good enough, so we'll go with it. But is good enough really good enough for us, or could we perhaps develop a better system of logic? And some logicians who debate this and other laws of logic, as well as other fallacies and formats of logic, say, hey, maybe we could do better, and maybe we should keep looking. It doesn't matter if you think that questioning this is absurd because, well, so what? Maybe it will lead to absurdities, but that doesn't mean we shouldn't question it or look into the matter. And even if it does lead to absurdities, maybe that shows that the law is correct. And if it doesn't, then, well, that could lead to something else altogether. But in either case, it will at least educate us more about this wonderful thing known as logic.